don't matter which x you put in there, you never get back 0. Let me get an example where it might work now. For instance, suppose we have this argument, x squared minus 1 equals 0. Then that polynomial has 2 real solutions. Or it has what? 2 real roots. What polynomial I'm talking about? X squared minus 1 equals to 0. How do I know that? Because I can solve that equation.
Sir.
Oh, Kevin is here. Good afternoon, Kevin.
Yes, hello. We just got in.
Okay,
So,
yeah, good afternoon.
So can you just quickly bring us up to speed on what we missed just now? If you can. I don't know if you just started. I don't know how long ago
We started about how many minutes ago it was now? We started about maybe 15 minutes ago because we're waiting for you guys. But
you know what the slides are? Of course, you didn't just start.
But no, actually no.
Let's see 5.
This is where we reached from last time, but because you guys were not online. However, what we have done, we have recorded. Well, I've recorded my voice. The voice is now being recorded for you guys. So the first part of this lecture, you'll hear it because it's been recorded now. It has been recorded now as we are speaking now. It's been recorded. But you have missed last week. But I've actually asked you to send an email to me with all your addresses, but I didn't get any email from you guys.
Oh, okay. All right. So you want us to send an email to you?
Yeah, because I gave my email address because I want to actually communicate with you guys to tell you what I'm doing each time.
Okay. All right.
So whatever you miss, I can send it to you by email, whatever either by way of additional notes or whatever I need to give you. So if you could just send your email to me after class, I sent my email to you already. So you could send an email to me and me put everybody email in. Put everybody's email in one email address in one. Like
okay.
Yeah, in other words, you could just say, okay, just remember what this is all about. Like say, Mr. Morgan, just 1 second, Kevin. Right, no, come on. I want to come on. The person teaching the manners, man. You guys come from. Guys, it's a person now. Can you imagine this? Okay, Cable, beg your pardon, right? I'm sorry, Cable. You could send an email to me, just address it to me by saying, remember what the email is all about. And in the same body of the email, you could put everybody's email address.
Right.
And I could communicate to you. Another thing I need to talk to you about, all right? I need to talk to you about other things that you guys are missing. Okay, do you understand what I'm saying?
Area.
Okay, so what I was doing today, we actually reached the topic propositional function. So I know you're now seeing the notes and that I actually put up. So if you have to go when the time comes and read from the beginning again and see what it's all about. But I'm going to send you some information that you need to know. That's important. So just remember to send the email now and I will actually send information you need, all right?
All right, yeah.
Good, okay. So what I was doing now with class, with Mona, I was trying to explain to them something called the existential quantifier and what is called the universal quantifier. And how do we use it in a statement? Because normally for the exam, the lecturers normally love to ask that. Like to express in symbolic form, if I give an expression, well, what I actually wrote on the board, which you cannot see, is that the polynomial x squared plus 1 equal to 0 has no real solutions. And also the polynomial x cubed minus 1 has exactly one real solution. Or I also use the word real root or no real roots. So, and I was actually showing Limona how to write it in symbolic form. But because the purpose of time and because I won't be able to go back over it now with you guys, I will actually send it to you by way of email. So I want to send an email that I can correspond to you. So whatever I'm doing now with them, I will actually send it to you by way of email.
Okay.
Everybody knows what I'm saying?
All right, yeah, I understand what you're saying. Yeah, we got you, sir.
So whatever I miss, I'm going to send it to you. Okay. So that's what I have to go back over that again. And then so I'm going to continue from where I left off now. Okay?
All right.
Okay, good. Okay, so back to what I'm saying now, ladies and gentlemen now. Okay. Now, if I'm saying the polynomial x squared minus 1 equal to 0, I would say it has exactly 2 roots. What am I talking about? The polynomial x squared minus 1 equal to 0. If I were to solve that equation, what do I get? Thank you, friend, thank you. I would get x equal to what? But to solve the equation, it's a quadratic equation. And we know the rules that because the I square is 2, we must get 2 solutions. But because if I make x equal to the formula, what do I get? I get x equal to what? Plus or minus the square root of 1. Because we have x squared minus 1 equal to 0. So x equal to what? Plus or minus the root of what? 1. Which equals what? Plus or minus 1. So I would ask, if I was going to get that expression, I would say show that, I would say express in symbolic form, the polynomial x squared minus 1 equal to 0 has exactly 2 real roots.
Excuse me, Mr. Morgan?
Yes.
Do you have, well, I noticed that you have a screen displayed, but it doesn't seem to be what you're talking about. Do you have that to
That's what I just said to you. That's what I just said to you a while ago, that I would send it to you when the time comes, because that's the part that you're not seeing.
Okay.
Okay, so I'll send it to you, all right? But I'm just continuing from what I was talking to Mona about. So, basically, guys, if we're going to express it in symbolic form, it would be, how do you write it in symbolic form? The polynomial x squared minus 1 equal to 0 has exactly 2 real roots. No, could you say for all x? No, what are the numbers that work for that? No, real roots mean it's where the graph called x-axis. So if I were to place 1 in that expression, what do I get? I get 1 squared minus 1, which is equal to 0. That means that 1 satisfies the equation. So 1 is the solution. If I were to choose negative 1 again, negative 1 squared equals what? 1. And 1 minus 1 is what? 0. So I know that it has 2 real solutions. So I can't say for all. I would now say there exists. Aha, look. I would say there exists x in R. Because we know what those x's are. What are those 2 x's? 1 and negative 1. I would say there exists x in R such that what? X squared minus 1 equal to 0. That would be the answer. All right, and I'm going to, Kevin will not see it, but I will say it to them later, don't worry. But the next one I wrote on the board is that the polynomial x cubed minus 1 equal to 0 has exactly 1 real root. Now, for you to know that it's true, ladies and gentlemen, you have to solve the equation.
Oh, yeah.
The polynomial x cubed minus 1 equal to 0 has 1 real root. Yeah. No, Kevin, did you hear what I said a while ago?
Huh?
Did you hear what I just said a while ago? The expression I use?
You mean x cubed minus 1, you mean?
Very good, very good. No, that has 1 solution, equals 0. X cubed minus 1 equal to 0 has 1 solution. What's the solution? What's the root? 1.
Oh, yeah, have 1, yeah, you're right.
Excellent, excellent. Now, if I were to express in symbolic form, how do I write that? I could say for all x, because I know all x work for that. I would say there exists x in R. But what is that x? 1. I'm not going to write that in the exam. I would say there exists x in R such that what? X cubed minus 1 equal to 0. Mona, do you understand what I said, Mona? Okay, Kevin, don't worry, Kevin. I was sending things to you. For you to understand what this was all about. So don't worry about it right now. You will see it in time what it was all about. But for now, let's continue on the slide that's online now, the PDF presentation. So what I have here, guys, is the question I had was a D equal to 2, 3, 4, which I just did a while ago. And I say I must express in either true or false, whatever. Now, why is now part 1 false? Because if I square x, I don't get back what? I don't get back x. Because x squares, what? 2 squares 4, and 4 not equal to 2, and so on. The next one, guys, part 2, You had chosen what? You had chosen what? 1 or 0. Let's see what the solution was. You see what was true? No, that one was false for the first one. This one was not true. Because we can choose the x in what? Integer. Because what you have done, we have now widened the domain to be what? Integers. So we can choose 1 as our answer or 0. Because when you square 1, you get back 1. When you square 0, you get back 0. So that is true, right, ladies and gentlemen? Good to go? Okay, very good. Okay, Kevin, so I'm back now to the presentation online, PDF presentation.
Okay.
Are you following me now?
Yeah, we're following you, yeah.
All right, so don't worry about everything, Kevin. I will give everything in time, don't worry. Okay. So just make sure you send me the email later, and I will have the addresses. Okay, so let's go on now to this now. Continue. Now, let's talk about now what I said now, ladies and gentlemen. The truth of no, I'm back to the original thing. Where am I? I'm back to the original thing. Oh no, this is where. Let's see, where am I? Am I on the correct thing that I want to be? Let's see. Is it jumping? Oh, okay. I think I'm at the right place, right?
Yeah.
Okay, guys. Important, very important. Now, the truth of a propositional function. Now, when I introduced this topic to you, I told you that the truth of a propositional function was based on the value of the what? The domain. What is the domain? The x value, right? So it's based on the dependent what? Okay. It is dependent on the value of the variable. It is dependent on the value of the variable. That's the truth of a propositional function. If I call x a variable, then based on the value of the variable, I will know if it's true or false. Don't forget that what I said to you initially. Now, what I want to understand now, ladies and gentlemen, is when is it true and when is it false? For the first one, the statement for all x, no, for all x, p of x. Now, don't forget that p of x is going to be a statement that you make. P of x is going to be a statement you make. X is the variable you're talking about at the time. Now, it is true. It is true if it is true for every x in the domain. What am I talking about? That statement for all x, p of x, it is true if it is true for all x in the domain. For instance, I could say like, if I say all natural numbers are greater than or equal to 1. Is that true? All natural numbers are greater than or equal to 1. Is that true? Yes, because 1 is the first natural number, so the domain would be what? Would be natural numbers, and the domain is infinite, because we cannot count the number of natural numbers.
Right.
Like the sand on the seashore, it's innumerable. So I'm saying to you that it is true based on the fact that the value of x takes 1, 2, and so on. So the propositional function is true based on the value of the dependent variable. So if x is true, then it is true overall. So look here, if 1 was, say, the first natural number, 1 is greater than or equal to 1 is true. 2 is the second natural number. 2 is greater than or equal to 1. Everybody understand what I'm saying? 5 is greater than or equal to 5. So that would be like a general statement. So that's why the first condition says that it has to be true for all x in the domain. So if I say for all x, p of x, it is true if it is true for all x in the domain. That's what it means for the first one. Now for the second condition, ladies and gentlemen.
Wait, sir.
Oh, your question, Kevin.
So 1, is that, so would 1 be a tautology then? Would that be
Tautology?
Would it be a tautology? Because
oh, you mean relative to truth table you're talking about?
Yeah.
Well, yes, naturally, but I'm not really linking up tautology to this now. I know you're still on the logic. Yes, because it will be true for all.
Okay.
If your argument is If your argument is such that I want to determine the tautology, then if natural number starts from 1 and it is greater than or equal to itself, x greater than or equal to 1, and x starts from 1 until the true because it's true for every single thing. But relative to a tautology, I wouldn't really use that right now.
Okay, all right.
Yeah, okay, but good question. Now, it is said to be false, ladies and gentlemen, if you can find 1 where it fails, it is false. So if I use for all, it is false if it is what? If it's that. If you can find 1 where it doesn't work. Now, this sum can mean 1, you know, guys. It can mean 1. Example, if I say all prime numbers are odd. All prime numbers are odd. I made a general statement that I use for all. All prime numbers are odd. But if I can find 1 example where it's not true, then that overall statement is not true. Now 2, for example, 2 is a prime number and 2 is not odd. 2 is even. Everybody see what I'm saying? Okay, so it's false, right guys? Very good. You understand, Kevin?
Yeah.
Very good, okay. Another example right there. All right, so I just mentioned that n squared plus 2n is an odd integer. And of course, if you can find 1 number where it fails, let's see if it's really true. So the example is that n squared plus 2n is an odd integer. So if I call p of n the propositional function, where n is a variable, it depends on the value of n, we can now give n value, or values. Now let's see, guys. Suppose I should give n values. Suppose n were 1, n was 1, n was 2, and so on. Is it really true? Do we get back an odd number? N squared, if I add, say 1.
No. The statement is false.
It's false.
Yeah.
Yeah, it's false. Very good. Because it only works for some number. It only works for some numbers, not all of them. I guess I didn't have a solution. I didn't have a solution for this one. Let's see. Sorry that. Kevin, am I when I'm talking, do you hear an echo?
No echo on our end.
Okay, very good, very good. Okay, let's see, guys. N squared plus say 2n. If n was 1, what do you get?
You get 3.
Is it odd? Suppose n was 2, what do you get?
You'll get n squared, that's 1. 2n is 2. 1 plus 2 is 3.
Suppose it was 2.
If you have 2n.
There's 4. 4 plus what? 4, so I get 8. So it's not true for when n is 2 is not true, right, guys? So look here, can you say that it is true when n is odd? If n were 1, 3, 5, it works. But if n were 2, 4, 6, you don't get back an odd number. Because if n were, say, 4, the expression is n squared plus 2n, guys.
Even though 1 is...
If n were, say, 4, for instance, then 2 squared is 4 squared is 16.
4 squared is 16.
4 squared is 16 if n were 4. 16 plus what? 2 times what? 4 is 8. 16 plus 8 is what? 24, which is not odd. So it is only true if n were odd. But if n is even, you don't get back an odd number. So the overall statement is not true. You understand, Kevin?
Yeah.
Very good. You understand, Mona?
Oh.
Understand? Okay. The next thing you need to know, ladies and gentlemen, is how to negate your quantifiers. Now, normally, we negate our quantifiers as follows. Now, don't forget now, there are 2 quantifiers that are introduced to you. the existential, which is there exists, as the name suggests, and the universal, it's a set for all. Now, naturally, when I negate is like you're doing the opposite, really, very good. If I negate the existential quantifier, it becomes the universal quantifier. So the negation of there exists is for all.
I wish we could see it.
So what we normally do, ladies and gentlemen, we negate the universal quantifier or the existence quantifier, the existential quantifier, and we negate the statement that follows. All right, it's there. I don't have to write on the board. It's there already. So if I'm going to negate, then look now. The for all becomes there exists. Let's see if I'm below. Right, it's below. Let's see it here. The for all becomes there exists. And then I negate the statement separately. Everybody follow me so far? Let me get an example. If I say all dogs bark. All dogs bark. Is that an example of a universal quantifier situation? I use all.
Yeah.
If I say all dogs bark, then to negate all dogs bark, the all becomes some, and I negate the bark, you know? Dogs bark, because dogs bark would be the P of X. Let me explain what I'm saying now, therefore. The all represent the universal quantifier all. Dog barks would be the P of X. So I must first negate the for all and get there exists. But there exists in this case means some. I negate dog barks and get. So what would I get then? Do not bark, right? So it says some dogs do not bark. You understand, Kevin?
Yeah.
Because after first negate the quantifier, and then I negate the statement. Okay, that's why I have what I have there. So I negate the P of X separately. And of course, similarly, if I negate that there exists, it becomes for all. All right? Yeah. I could say there is a student who likes to party. There is a student who likes to party. What is the negation? So I say, well, all students
do not like to party.
Is it do not like to party? Because the PFX would like to party. So the not of that would be do not like. So all students do not like to party. So you have to negate the statement after. The time will come that I'm going to show, ladies and gentlemen, some real stuff, or to negate some inequalities. Those are the killer ones. Those are the killer ones, the inequalities to negate. And also the implication to negate, like P implies Q, that's a killer one as well. Okay, and of course, like the example, I wrote them back here for you. Wow. All dogs bite. Well, I said bark, but I use bite this time. All dogs bite. Some students party. And I combine them using the and. All dogs bite and some students party. So we're going to negate those, ladies and gentlemen.
Some students like to party.
So the all becomes some. The dogs bite becomes do not bite. Very good. Are you following me, Kevin? Are you following me? Part one.
If we were negate some dogs do not bite.
But I said at least, you know, at least. Okay. at least one dog do not bite.
Oh yeah, all students do not.
And the other one now I combine, so it is all students do not party. And I had some students what? Some students what? Party. And I combine them using the and now. But ladies, can I talk to ladies and gentlemen? When I negate, the and becomes or, and vice versa. So the and becomes or. So I combine them, I combine parts 1 and parts 2 together, and I use the or instead of the and. So you have to negate the statement, you have to negate the quantifier, and then don't forget now the or becomes the and vice versa. Everybody up so far? Good to go, guys? Okay. Do you understand, Kevin?
Well, yeah.
So I can move on then.
Yeah, you're good.
Okay, very good, very good.
When you negate, you get or.
And the last thing you need to know now on quantifiers is when we have the combination. It's called multiple quantifiers. Now this is very important, ladies and gentlemen. Now, if you look at your tutorial 2, number 2. Okay, Phil, did you get the tutorial papers I sent?
No.
Yes. Oh, yes.
It's an OURBLE, but I sent it to the tutor that's supposed to be teaching you guys.
No, then we did not get it. The tutor's supposed to bring it.
Oh.
Oh no.
It's an OURBLE, you know, those 2 tutorials.
Okay.
Yeah, but I also sent it to the tutor. But we'll talk about that. We'll talk about that later. Okay, look here now, ladies and gentlemen. No, the double. No, whenever you have them, whenever you have the quantifiers now, a combination. No, the multiple quantifiers mean it can come as there exists for all. We could have there exists for all or vice versa. We could have any of those combinations. Now, when I negate the multiple quantifiers, this is what I get. Oh, by the way, I should tell ladies and gentlemen that they are not the same. There exists X for all Y is not the same as for all Y there exists X. All right. I don't want to jump the gun, but the example I normally use, let me not jump the gun. But don't forget now that there exists X for all Y is not the same as for all Y there exists X. So the order of the quantifier, the order of the quantifiers matter. Okay, let's see how we indicate them now, guys. Let's see how we indicate them. Oh, I didn't show indicate them. Did I say it up there? Okay, if I have for all X, for all Y, now notice in my bracket now, in my bracket I will have 2 variables, X, Y. Because it's a function of 2 variables now, X and Y at the same time. So if I say for all X, for all Y, the negation becomes there exists. For all there exists becomes there exists for all. I have to negate the statement separately, right?
Wait, you can repeat that, sir? You can repeat that? You kind of lost me at that part.
Okay, I didn't, all right. To negate the multiple quantifiers, I'm saying that you have there exists for all there exists, or for all. It can come in any of those combinations. You understand?
I think so.
You understand, Kevin?
You have an example prepared? Do you have an example prepared?
Yeah, man, I'm going to give an example, but I'm saying to you that it can come as for all, there exists. Let me go back one. So Kevin, hello?
Yeah, let me hear you.
Okay, you hear what I said a while ago?
Repeat.
I was saying that to negate the multiple quantifiers,
Right.
nothing changes. If I have there exists for all, then the negation of there exists for all would be for all there exists.
Oh, okay.
But I'm saying that as it appears, they're all saying something different. What am I saying? There exists for all is not the same as for all there exists. It means something different.
Yeah, yeah.
All right, I think I want to finish right here, but so okay, Mona, talk to Mona. Talk to you later, Mona. Okay, Mona, we'll see each other tomorrow. Kevin, what I'm saying to you now, okay. Send me your email address now, your email address, and then now I'm gonna send some stuff to you guys.
Okay.
Right, Kevin?
All right. Yeah, we're getting the emails together.
Because the time is up now, and the classroom is now being occupied by different people because I have to leave the classroom. So send me your email address, and I will send some stuff to you soon. That's what you need to know. All right?
All right. So we'll go email.
Okay, so we'll talk to you soon, Kevin.
Pardon?
So I'm saying that, so I'll talk to you later then. I'll talk to you later. I'm going to go now.
Wait. Miss Margaret?
I'm not hearing you.
Is Miss Mega there?
Say it again.
Is Miss Mega?
Oh, no.
I'm online.
Okay. We're not pleased at the fact that we were not able to join earlier today, and the class started without us.
You mean today?